Here's a different idea. We and everyone in the whole world always talks about pH of a solution. The pH of the solution is 5. The pH of the solution is 8. The pH of my pool is 7.2. Well, if the pH is a measurement, a logarithmic measurement of how much OH there is, how much H there is in terms of logs, then there is also, I suppose, a scale called pOH, which conceptually is exactly the same. It's a measurement, a logarithmic scale that measures how much OH there is. And so everyone in the world uses pH, but there's no reason why we couldn't use pOH to measure how much OH there is. Now, the other thing that's interesting is that means that if the OH level was 1 times 10 to the minus 3, that means the pOH for the solution should be 3. This also means for that same exact problem that had the OH level of 1 times 10 to the minus 3, and we found out that the pOH should be about 3, for that same solution, the concentration of H plus should be about 1 times 10 to the minus 11, since the H and the OH should always multiply together to equal 1 times 10 to the minus 14, the kW value for water. Likewise, if the H plus level for this solution is 1 times 10 to the minus 11, it means the pH should be about 11, which an interesting fact means that the pH and the pOH should always add together for a solution to equal 14, just as the hydronium ion concentration and the hydroxide ion concentration should multiply together to equal 1 times 10 to the minus 14. Now here's one more problem for you. Well, here's a sort of a different problem for you. We're going to go backwards. I'm telling you that the pH for a solution is 5, and I want you to find 3 other facts about the solution. Like I want you to find the concentration of H plus, I want you to find the concentration of OH minus, and I want you to find out the pOH. You should probably pause this video and find out those solutions and then come back. Okay, here are my 3 solutions. And it really doesn't matter what order you go in. They all represent their set amounts in the solution. Most people probably, when they see a pH of 5, they may decide right away to find out the pOH first. Since the pH and the pOH have to add together to equal 14, that means that for this solution, the pOH has to be 9. Now for me, I did this. I said the pH was equal to the opposite of the log of the concentration of H plus. So in this case, I know the pH is 5, so I want to find out the log of, so I want to find out the concentration of H plus, means I have to raise 10 to the minus 5, which should be the concentration of H plus. Since log means what power is 10 being raised to, in this case, I'm raising 10 to the pH power, the opposite pH power, to find out the concentration of H plus. And then lastly, the H plus and the OH have to always multiply together to equal 1 times 10 to the minus 14. So I just divided 1 times 10 to the minus 14 by 1 times 10 to the minus 5 to find out the OH level. This is what I was trying to point out, is that the pH is equal to the opposite log of the H plus concentration. We know that's pretty much true. So if you want to do the exact opposite thing, where you want to find out the concentration of H plus, you can raise 10 to the minus pH power, and that should equal the concentration of H plus. Likewise, we know that the pOH is equal to the opposite of the log of the concentration of OH. So I suppose that 10 raised to the minus pOH power should equal the concentration of hydroxide. Last thing, we learned that the pH is a logarithmic scale, and pOH is also a logarithmic scale. And you're going to find out that there are lots of other logarithmic scales that are used in chemistry and physics, and a lot of them start with P whatever, like pH, pOH, and pH is the opposite log of hydronium, H plus. And pOH is the opposite log of OH. There's also what's called pKw, which is the logarithmic version of the equilibrium constant for water. And there's pKa, there's pKb, there's pKsp, there's lots and lots of them. But the one I want you to think about is, what about something called pcat or pdog? What would those measurements look like? Well, pcat, I suppose, is measuring the concentration of cats, but it's doing it logarithmically. So pcat would equal the log of the concentration of cats. So that little old lady that lives down the street that has 10 to the fourth cats, 10,000 cats, her pcat level, I guess, would be 4.